So let's talk about abstraction. And I'm going to try to make it as concrete as possible, but it's kind of an abstract topic, so it's a little bit difficult. So I'm going to encourage anybody, if the things that I'm saying don't make a lot of sense, if you're having trouble understanding the idea I'm trying to convey, please raise your hand and ask a question, because if you are, then probably other people are too. But if questions start to veer a little bit off topic, then I'll ask to just kind of hold them off, and I'll move on, and we can circle back around at the end. So before we dig into the actual topic, I think it's helpful to understand a little bit about the perspective that I have coming into this. So I've been working at Atomic Object for a long time now, and I kind of personally believe that whatever you do for a really long time shapes how you look at things and how you approach things. And this talk is very much informed by the perspective that I've kind of built up doing what we do here, which is we build software for customers. They usually hire us to build kind of the first rev of a project. We build something out over the course of 6 months, 9 months, and we charge by the hour while we do that. And we also work in an agile fashion. And so my perspective is very much informed by really needing to kind of deliver value on a consistent basis, having kind of measurable value, getting things done effectively for customers, and having them feel that they've gotten out of the engagement as much value as we can possibly deliver. I was talking to a friend recently about how it is that I approach building a new feature, and I realized like we had pretty different ways of approaching it, and I think a lot of it comes down to that like difference in background. And so I thought, well, I think this is something that's worked out pretty well for me, working in the different contexts that we work at here at Atomic, so maybe it'd be helpful for other people too. So for me, when I'm working on a project, for me, it's really important that we deliver great value to that customer, that we deliver functional software in a cost-effective way. And as things change over the course of the project, a real test that I have for whether or not I've engineered things well is how often do I get to say yes? If a customer has some sort of request that we weren't anticipating ahead of time, how much flexibility do we have to maybe just kind of get that extra feature in, be able to go that extra mile without them having to change their project budget? So for me, the only real way of achieving that is to have sustained, or even better, increasing value delivery over time. So this chart was shamelessly stolen from Rich Hickey's Simple Made Easy talk. If you haven't seen that, you really should. It's really great. But he makes the observation in there that when you work with something like, say, Rails, which I've done a lot of work in, so I'm picking on it because I got a lot of experience there. It can make it really easy to start out getting things done really quickly early on. But then over the course of the project, you start accruing technical debt, things start getting more complicated, and when you want to go in and add a new feature, over the course of the project, it gets harder and harder and harder. And what we really want is something where, even if it means we can't go as quickly early on, as we move forward and we build out more of the software, what would be ideal would be a situation where we actually can deliver more value per hour worked over time. And we can kind of see like an increase in productivity over the course of a project. So that's my goal, and that's what this talk is really about, like one way of trying to strive for achieving that green curve. So we have a lot of different ways of doing this. Simple Made Easy being one example of kind of one approach of trying to do that, having simple components and artifacts, or simple components and simple abstractions and ideas that lead to simple artifacts. But then there are other things that we can do too. So I've been using a lot of Ember.js a lot lately on front-end development, and the data binding mechanism they have there is really powerful. And that allows me to get a lot more done a lot more quickly. We use kind of type systems and automated tests as ways of catching regressions and helping us avoid the slowdown that can occur as your system gets more complex and one bug compounds with others and complicates things. And then another thing that we all do is when we come across something repetitive that we're doing again and again, we write software to help make writing software more easy and more productive by automating away those repetitive tasks. But really all of these different approaches avoid slowdowns or kind of constant time improvements or maybe linear improvements. But how can we kind of achieve a non-linear increase in productivity? And the only real way that I've seen that, for me, achieves that effect is through really powerful abstraction mechanisms. And to me, what that means is really just clearly thinking through what it is you're trying to do, expressing that directly and clearly in code, and building up tools yourself to help accelerate your own development. So I think there are two big reasons why good abstraction can lead to this sort of powerful effect. And so the first is what I think of as flex, which is when we start a project, we have a good idea of what our customers want, or we think we do, and we start building something that'll do what it is that they've asked us to write the software to do. But over time, things change. We learn more about the domain. There are evolving business realities. Somebody just saw something and they decided they didn't like it, and they had enough clout to ask us to change it. So we have to respond to that change. And if we build software that's not flexible enough, then we end up in a situation where we have to break things or throw them away in order to respond to those changing needs. So we might go and we might try to create something that's really abstract and really general. But the problem is if we do that, if we spend too much time creating things that are really general, that generality doesn't come for free, and it slows down our development pace. It's harder to implement. And then the other thing, too, is we've invested in flexibility that we don't necessarily really need. So going back to what we do at Atomic, we're working to deliver value at an hourly rate. We're trying to achieve kind of the best benefit of having not over-investing in that generality, but getting just enough of it that we can respond to the changes that our customers are likely to need. And so we're aiming for this kind of middle zone, having a good understanding of the nature of the business and the nature of the need that our software is being designed to meet, and using an understanding of that to inform where do we need to generalize and where do we need to not generalize, what's going to pay off, and trying to just create software that flexes in just the right way so that the things that are likely to change or that may change, we're better equipped to flex and respond to, and the things that are just impossible due to the nature of our customer's business, we haven't invested time in generalizing in that way. So I think that's one reason why I think that good abstraction can really help. And another reason is leverage. And this kind of, to me, means when you've built a tool or you've built out a concept and you have that kind of expressed in code, it allows you to do more with it maybe than you intended originally. And when you have powerful tools that are kind of orthogonal to one another, those things tend to enhance one another and be greater than the sum of the individual pieces. And each one of them enables you to do more with the other than they could have done originally. So for me, this idea is about investing time and doing things well and thinking things through and aiming for solutions that will amplify your ability to get things done in the future, even if you don't know exactly how you might call on them to do so. And I think that when you aim for these two things and you kind of go through trying to maximize both of those, investing in just the right type of generality and looking for things that'll build leverage for you, at least what I've seen, and I'll kind of try to demonstrate this at the end of the talk, is software that to me looks different, or at least it feels different. When I think of a Rails application, and this is true of like a lot of different frameworks, it's not just Rails. The same thing happens in building iOS applications a lot of the time. You kind of have this framework, it's a set of ideas, you've got controllers, you've got models, you've got views, you have these things that serve a different niche, and you kind of apply the same pattern again and again and again. And so to me that kind of looks at like this sort of horizontal shape, where you've got one screen that you're building out, so you're going to create your view and you're going to create your controller, and you've got another one that you're going to build out, and you're going to kind of repeat those things, and you're sort of building on top of the tools that the framework gives you, and you end up with a sort of horizontal shape. But when you're seeking out more powerful ways to solve your own problems and building up the kind of conceptual tools to really solve your problems well, which to me I think of it as I'm starting with Rails, but then I'm trying to build up the framework to the level of the problem that I'm trying to solve, and not just this generic web development problem. Then I think you end up with something that's a little bit more, I think of it as kind of triangular, which is that you have a large amount of the intent of what you need to do is expressed in a very small amount of declarative, clear code. And there's still this sort of horizontal aspect because fundamentally you have a certain amount of scope that you need to get through. But you end up with something that's a lot more kind of concise at the top. So I guess that was maybe not the most clear explanation, but when we get to the end, I'll have an example that I hope will help draw it out a little bit better. So to me, the kind of fundamental principle of trying to aim for this, we have these goals of leverage and flex, but how you go about doing them, you don't have to keep your eye on the big picture and constantly be optimizing at a macro level. I think that there are these sort of like lower level micro scale things that you can do on a regular basis that help you accomplish those things. And to me, the most important one is that we should judge code not by cleanliness or efficiency, but by how well it expresses core concepts and the soundness of those concepts. So to me, every piece of code that I see, I can read as a process that a computer will go through to accomplish some sort of end. I can look at it and I can think of how is it going to execute, what's the computational complexity, what kind of memory use is it going to have. But another way of looking at a piece of code is what are the ideas that it's dealing with, and what is it saying about those ideas and how they relate to one another. And to me, it's that last perspective that's the most important and how I want to approach everything. Or at least what I'm talking about here today. So there's no silver bullet here with making this easy. To me, this is like the defining struggle that we all go through to get better as software developers. Fundamentally, this is think good and write good code. There's not really a way that you can kind of throw that out there and make it work. And this isn't going to just like churn things around, but I think it's a way of approaching things and thinking about things. It's both a process and a vocabulary for trying to get better at this collectively. If you're working with other people at work and you can try to solve problems in this way, try to get better at it, and that's really what I'm trying to go for here, is just sort of a way of thinking about approaching problems and maybe a way about talking about them. So, and that process is what I'll call ontology-oriented development. It's basically my gambit to make millions of dollars by entering into the industry of software development processes. So here we go, patent pending. Basically, overall the process kind of goes something like this. First, understand the business need. Understand what it is you're trying to accomplish in a deep way. Once you kind of understand the business need, you kind of need to look at that and figure out what's new and what's not new. And I think of that as factoring this feature you're going to implement into novel aspects and familiar aspects. From there, you take a look at the existing concepts, the way you've been thinking about the problem you've been solving all along, and look at ways that you can generalize those ideas to help solve some of these new problems. And from there, you need to maybe generate new ideas to solve problems that you were never equipped to handle to begin with. That's when you write the code, once you've kind of done this forethought, and then you can apply this process recursively. So you do it at the start, at a high level, when you're thinking about architecturally, how's this software going to work, but you can do it at a micro level too, when you're writing a single function, and you can't express things as clearly as you would like. You can take a step back and maybe say, what's that saying to me about the business need and the nature of things? So, understanding the business need. Let's get into that. And I think before we can really get into what I mean there, I think it's important to talk about models. So, when you sit down with somebody who's maybe like a product manager or a customer, a lot of the time they'll tell you what they want and they'll use language that's inconsistent or maybe contradictory. They might draw an interface for you and maybe that interface doesn't really make a lot of sense. A lot of the time people haven't really thought things through to a level of clarity that you really need in order to be able to write software around it. So when I use the word model, I don't mean necessarily a formal model, but what I mean is a really clear, unambiguous understanding of what it is that you're talking about. So really thinking about what are the ideas, how do they relate to one another, what are their boundaries, what are their responsibilities, and what are their constituents. So when I say understand business need, what I'm really kind of talking about are the relationship between these three things, at least really this first one. So when I'm sitting down with a customer and we're talking about the software that we need to build, the first thing that I see myself needing to do is understand what it is that they do. What is the context in which this software is being used? And so when I say understanding the business need, what I really mean is to help clarify that ambiguous language and resolve those contradictions, at least internally in my own head, and kind of derive a business model for what it is that we're talking about, what it is that this customer does. But we're going to be building software, and the software that we're building is not necessarily exactly related to what it is that our customer does. So while we need to understand what it is that we're building the software for, I like to distinguish between the business model, what's the broader context that the software is being used in, and what's the domain model. What are the ideas that are important to the software that I'm building in order to solve an acute problem? It could be a subset of the domain model. It could be something completely separate from a subset of the business model. It could be something completely separate. So we want to understand the business model, and the reason is because it's going to help inform how we establish our domain model, the ideas for our software. And then the reason for that is because ultimately we want our program to be an expression of those ideas in our domain model. So step one, understand business need. We're talking about a clear understanding of the business domain at sort of a level and precision of models. So step two is factor a feature into the familiar and the novel. So I think of this process as we're learning about a feature, we're clarifying what that feature means for us and using it to help better understand the business model, and that's so that we can kind of generalize and update our conceptual model to better understand what it is that we're trying to do. Sorry, I think I got off track there for a second. Now here we are, step two. Factor feature into familiar and novel. What I mean by that is whenever we're tackling something new, even if we're starting a new project, when we're starting a new project, we have frameworks and languages that we're building on top of. Those come with ideas built right into them. Maybe it's object orientation. Maybe it's MVC. Like there are things that are going to be there whether you built them or not. But more likely than not, when you're creating a new feature or you're adding something new, you're adding it to software you've already been working on. And you have an existing way of looking at the world, an existing domain model through which you can look at the thing that you're trying to accomplish. So once you kind of understand what it is you're trying to do, the next step is to take a look at, well, what if I look at this feature that I'm trying to achieve, what are the aspects of it that are neatly accounted for in the domain model that we already have? What are the things that basically are just another example of a pattern we've already established, or that I could implement really easily in terms of concepts that already exist? But then there are other things that don't fit as neatly. They're awkwardly expressed, or maybe there's just no way to express them. And these things that don't really fit, or you can't really explain in terms of the ideas that you already have, I think of these as novel aspects of the feature that you're going to implement. So once we understand what it is we're trying to do, and we have an idea for how we're going to account for the sort of the familiar aspects, the next step is to figure out how do we resolve this novelty? How can we take these sort of new things, and by adding new ideas and by amping up the power of the ideas we already have, how can we resolve them and turn them into things that are sort of familiar? So the first way to do that is to generalize existing concepts. Take those ideas that we already have, and the things that don't quite fit, maybe we can just add a little bit more expressive power to them, or maybe we can generalize them or decompose them in a way that will help us account for some of the new things that we're trying to do. But if not, we might need to introduce new ideas into our domain model, new ways of thinking about things in order to talk about the thing that we're trying to do. So I don't really have really great advice for how to do this stuff. Like I said, I think this is hard. I think it's just like thinking and getting better at it and learning tricks. But I do have a rule of thumb that for me has worked well. And that comes down to sort of the general versus the specific. And YAGNI is a thing. You ain't going to need it. Like when we don't want to prematurely optimize, and we don't want to spend a bunch of time creating these super general, wiggly things that aren't going to give us the bang for the buck. But at the same time, writing code is an opportunity cost. Every time you're writing code, you're writing that code that you're writing. And usually there's like a certain amount of work that you need to do. Like if you need to move a boulder from here to there, there's a certain amount of force that's going to have to come into it one way or the other. And I think a lot of things that we do on a regular basis as programmers are the same type of thing. Like ultimately, the simplest way I can possibly do this is going to take me 4 hours. If I'm going to spend 4 hours writing code, is there better code that I could write in that 4 hours? And to me, this is about the idea of seeking out the maximally general, pragmatic solution to the problem at hand. So the reason for this, it comes back, one, to leverage. If you write really specific code that's just solving the problem at hand, then you end up with something that does what it is that your customer asks you to do, but you're not creating leverage for yourself. You're not generalizing on that particular problem and creating something that you'll be able to reapply in the future if a similar situation comes back in the future. So we really want to create this leverage, and I think one reason that this leverage comes about, and one thing we can look for while trying to create it, is synergy. And by synergy, I don't mean nacho-flavored Mountain Dew. I know that's the first thing that everybody thought of. Like, I don't mean what I mean is when you have general things that are orthogonal to one another, that kind of work in different ways, a lot of the time you can combine them in novel ways and solve problems that you never expected. So it's about seeking out things that will amplify the things that you already have. And these are a lot of the time that you can kind of do this with some simple thought experiments as you go. What are ways that you could maybe combine one potential solution with the things that you already have, and will that help you solve plausible things or things that you know are just coming up in the near future anyway? So you can kind of look for those as you go. So with existing concepts, we're looking to leverage existing thought. And we're looking to generalize them as much as possible to accommodate the things that are awkward fits. But for new concepts, we want to look for things that are going to provide leverage for sort of upcoming features or things that are plausible features. We're preferring ideas that synergize with our existing concepts and try to give us more of that leverage. But at the same time, we don't want things to be too general. We're trying to make smart bets about how we're using our time. We're trying to create the thing that's going to deliver the most value over the course of a project, and that's a lot of stuff. That's if you're charging by the hour, it's how many hours did you spend working on it. If you're creating something that's general, what's the likelihood that you're going to be able to recoup the value from leveraging that generality? So we're looking for things that are the maximally general, pragmatic solution. So, you know, general enough to maximize value, but not so general that we just blew our budget creating a hyper meta framework that could solve arbitrary problems in the future. Ultimately, we're trying to seek that sweet spot between things that are too specific to give us flexibility and so general that we can't really recoup the investment that they need to make. So the way that I kind of think of this is we have a problem that we need to solve. And you know, we could think of one way of solving that problem, maybe the most straightforward, but maybe we spend a few more minutes and we think of, you know, what are a handful of plausible ways that we could tackle this problem? Not writing any code yet, but some of these are going to be, you know, maybe less, like more specific and less general. Maybe some of them are going to be really general. And maybe we've got a sense of how much value each of those might give us. If based on the things that we know are kind of coming down the pipe. So we could maybe look ahead into our backlog and say, what are the features that we know we need to implement, and how do each of those relate to that future work? Then we say, like, okay, well, how much time do I think it would take to implement each of these features? You know, maybe one of them, the simplest one's going to take 8 hours. I could get a little more generality if I spend a couple of more with this other approach. This other approach, maybe that's too much time and I can't afford that within the budget I have. So then you can kind of use that trade-off of your informed sense of what you might be able to get value from, and kind of compare that to how much time you think it's going to take, and try to make the best choice for how it is that you proceed. So then, you know, once you've kind of done all this thinking, I mean, we haven't actually written any code yet. We've just been trying to seek out the best approach to take, the thing that's going to give us the most bang for the buck. That's when we can dive in and start to implement. And this goes back to the idea of writing code and evaluating code not by how efficient it is or how clean the syntax is, but instead how well it represents ideas. To me, this is the idea of a program not as a process, but as an ontology. So this is something that I found in Wikipedia describing a formal representation of a conceptual model. And to me, this actually works out pretty well. The way that I think about code is, you know, it is a process, and it does need to do what it needs to do in order to be successful. But the code that I'm writing, I think of it as an expression, a story in terms of the ideas that I have in my head, in terms of the domain model that I've spent a lot of time thinking about. So think about your code as an ontology, as a representation of the way that you think about things, and make sure that it's a good representation, that it's an accurate representation, that you're not telling lies in your code about how it is that you think about things. So when I sit down to write code, and I hope a lot of you do the same thing, I ask myself, how is the best way that I can express my intent and how I think about things in terms of the domain model, in terms of these ideas that I've been spending so much time kind of carefully thinking through? What's the best way I can express my intent in the syntax of the language? So not trying to pull in like Englishy code patterns into your code base, but instead just trying to look for a natural way within the structures that the language presents of expressing your intent in terms of the way you think about things at a pretty high level. And I think of evaluating code from this perspective as looking at it through the ontological lens. We're ignoring all the process pieces. We're ignoring maybe even sort of the cleanliness. And instead we're just looking at what is this saying about the ideas. Maybe if I see a class, I think of that as establishing the existence of a concept. I look at maybe the properties on that class or the methods on that class. It's telling me a little bit about what do I think of the responsibilities of that class being. Things that are composed into it are, to me, a symbol of how do I think about this idea in terms of its most natural other ideas to express it in terms of. So this to me is kind of the activity that I'm doing on a regular basis and that you can do at a regular basis to help achieve some of these goals of leverage and flex. So when you're looking at code from this perspective, you're going to do your best to kind of express things in a natural way, but ultimately you have a budget that you're trying to work to, and you can't necessarily do everything in the most right way, or it doesn't necessarily make sense to do everything in the most right way right away. The other thing is nobody's perfect, and you're going to maybe have some ideas early on that don't really pan out. Maybe you need to break them down. Maybe they end up being a little bit awkward, or maybe you just learn more about what it is that you're trying to do, and you realize that things weren't exactly right. So to me, when you have that mismatch between how it is that you're currently thinking about things, like the sort of state-of-the-art ideas that you have for approaching the problems, and you have a mismatch between that and how things are expressed in code, that's sort of this like cognitive dissonance. And really, I think that's something that we want to minimize. We want our code to never tell lies, as much as possible, trying to remove that dissonance as we go through and write our code. So, and then, we do that and we iterate and we recurse and we keep trying to improve things and we keep trying to look for hints of maybe expressing a concept awkwardly in code. Maybe that's a sign that we need to rethink some higher level concepts. Or we're tackling a new feature. Maybe we need to go back and rethink things. So that is really not super actionable. I mean, it's a little bit of a process you can kind of walk through and do it and practice it. But the last time I gave this talk, people came up to me and they're like, okay, well, you didn't really say anything. And I was like, okay, that's a good point. I don't really know that I have that much more that I can say, but there are some things that I try to do as I go to try to do this. I don't have a lot of specifics here, and so if you guys have questions afterwards, like I'm happy to try to dive into more detail. But one thing that I try to do is maximize data and minimize code. And if you think about what code is, it's this sort of imperative expression of process. It's telling the computer, do this, then do that, then do this other thing. Like what it's really talking about is computation and movement of data. Whereas data just kind of sits there and expresses what it means. It's something that's first class and manipulable. That's really kind of what you want in order to be able to build up the language, build up your abstractions to be able to be something that can give you a lot of power. Look for opportunities where you can maybe take something that you would have done in code and transform it into data. And that can mean maybe pulling something out into a YAML file or XML or JSON or whatever. But it doesn't necessarily have to be that. Maybe it could be a way of expressing yourself more declaratively in the language that you're writing. Whether you're writing a high-level language like Clojure or something, or writing C#, there are a lot of ways where you can look to try to express yourself in a higher level way. In Java and C#, I think of fluent interfaces as a good example of this. So another thing that I try to do as well is look for ways that I can introduce orthogonality into the solutions that I'm introducing. So let's say you found some nice way of taking something out that may have been spread across a whole bunch of implementations of different web pages or iOS screens and turned it into something that's a little bit more data-driven. It can be really tempting when you do that to add more and more and more capability to your way of solving problems by adding more flexibility to your data representation, more ways of accomplishing additional things. And if you do that, what you end up doing is kind of adding lots and lots of stuff to one potential solution. And sometimes the better way of approaching that is to look for a different way, maybe try to stratify yourself between different concerns and have a different solution to some stuff than you do for other things. And one of the things that comes out of that, or at least has for me in the past, actually a good example of this is we had an application where we had a lot of different pages that were really, really similar. And so the straightforward way of solving that problem would have been to create a bunch of different pages, put the different content on each of them, and then, then you're done. And we took a step back and we said, well, how can we think of this as each of these pages not as like an ASPX page or something, but instead as an expression of data like that's coming from a model. So instead of the last part of our URL component being the name of a page on disk, instead it's maybe the name of some sort of model, even if that model isn't coming from our database. Well, we ended up implementing a lot of the structure of our application or describing it in a YAML file, and that built out a lot of the user interface. But then we had all of these needs where we needed to add data or add presentation logic, and if we tried to add that to that YAML file, it would have just gotten really crazy really, really quickly. So instead we added a different mechanism to express customization of presentation that worked in a completely different way from the expression of the application structure. And then those two things ended up having like a really nice play off one another where they worked in really different ways, and it ended up being a lot more powerful, a lot more flexible than it would have been if we kept trying to add more power to the existing data-driven mechanism we had. And then the other thing is look for things that are composable, things that you can like recombine in different ways, or abstractions that can be sort of implemented in terms of themselves. Because when you do that, you can have you end up with something that you're much more likely to be able to recombine. That's more likely to give you leverage in the future. So I'd like to take a look at a little bit of an example that comes from a project that I was working on very recently. We were creating an application, and this was a reporting application for companies. So you were maybe looking at data for a particular company, and you wanted to be able to report on what are the different types of contracts these employees have with the company. Are they full-time, part-time? How much money are they making? And then wanting to be able to kind of slice and dice the organization by maybe location or employee status, look at different time spans. And be able to then see, as you interact with these sort of filters at the top of the screen, be able to see the data animate and respond as you interact with it. So I'm going to focus on this one example of maybe we've got part-time, full-time, salary, hourly, number of contracts within a particular part of the organization. But in this application, there were several different pages where that could be filtered in different ways, and each page had a lot of different visualizations of the types of things that they would want to see. So when we were tackling this problem, we were looking for how can we find a solution that's going to give us a lot of leverage, that's going to help us solve as many of these problems as we can in a way that doesn't take a crazy amount of implementation cost. Before we dive into that, the other thing is there are a few different problems related to making something like this happen. So on the one hand, we need to actually analyze the data. So we have these filters that we're going to be interacting with that are expressing constraints on what it is that we're interested in. So step one is how do we kind of take those constraints and get the right numbers back to show to somebody. So step two is once we get that data back, we need to talk about how to actually present that data to the user. And then step zero, because I forgot this one already, is how do we express a relationship between the components that we have on screen and the filters, that the constraints that those need to add to the data. So each one of those is kind of a different concerns here, and we tackled each of them differently. So starting in the middle, I guess, with how is it that we can go and analyze the data and get the numbers that we want. Looking at this from the standpoint of we're going to be presenting information to users and we want to have constraints on that, we thought to ourselves, like, okay, well, we could go and we could build APIs for getting employee data, getting contract data, maybe different API endpoints for getting different kinds of facts. But we realized pretty early on that there are these things called OLAP cubes, which I hadn't really used before, but they're kind of perfect for solving this kind of problem. And if we could kind of just think of our application not as reporting on companies' employees, but as just a reporting system that where the reports kind of worked within a certain pattern, maybe we could get more leverage out of the work that we would do building the API endpoint. So we created an API where we could kind of post to an endpoint an expression of what it was that we wanted. Maybe we want these different the number of people with these different contract counts, and we could express constraints on what it was that we want in this sort of JSON syntax. And basically all that would turn into is a compiled SQL query that would fetch the numbers that we want, and then we'd send back a pretty simple representation of the data that we had requested. So once we had this problem of, okay, we're going to be sending these sort of queries to an endpoint that's going to be delivering us value, we needed to talk about how do we translate that down into SQL queries. Instead of having a bunch of special cases for each possible query or where clause, we instead said, like, okay, well, let's introduce a syntax for expressing how it is that this API works. What are the sort of OLAP cubes under the covers that feed this? And how do we transform a request into the corresponding pieces of SQL? So then we had an API that we could send some JSON to and we could get some numbers back. So then we had this other problem of, well, we want to put some widgets on the screen and we want those widgets to express constraints on the data. So how can we most directly and declaratively express the relationship between what we have on screen and how that impacts what we show to the user? So in this case, we were writing the application in Ember.js, which has a really powerful data binding mechanism. So we use Ember's built-in mechanisms to data bind the values of form components to just some variables on this object. And then we added a pretty simple syntax for expressing a relationship between a variable and the dimensions on the underlying data that we wanted to have be constrained, and how to interpret the value of that variable in terms of a constraint. And then these conditions, the constraints, were kind of applied to a set of analyses, which were the types of data that we want and that we're going to be using to present in different ways. And then finally we said, okay, well, now we have this way of basically doing AJAX requests and pulling in data in response to a user interacting with a form. And we're getting a whole bunch of data back all in the same format, because every time we interact with one of these or express a new analysis, it's always sending a request that's in one structure and getting back a response in another structure, parameterized by the actual thing that we asked for. So what's the most natural way that we can establish a correspondence between the data we get back from our API and how it is that we want to present that on screen? So we used, in this case, not like data. So the first couple of examples, the JSON that we were posting and the YAML file, were just straight data that our application was consuming. In this case, this was kind of more like a DSL. It's data, and actually this is all just JSON. But in this particular case with presentation, it didn't really make sense for us to try to create something that was just pure data. We just created kind of a little helper that we could parameterize to express how do we relate the data results we get from our contract breakdown query, how do we map that into the data we want to feed into a bar chart in order to show that on screen. So each step of the way, it was kind of a question of how can I most succinctly and clearly express my intent in terms of the syntax of the language I'm working in, or in terms of maybe a data structure I can express with something I have tools that make it easy to implement. What are the most general ways that I can solve these problems? And then ultimately, none of these things were things that we were necessarily convinced we were going to dive into. They were things that leveraged the tools that we already had in Ember or in whatever language we were building on, And at every step of the way it was, what's the thing that we think we can build? Maybe it takes a little more time than the most straightforward thing, but that can maybe pay off for us in the long run by that we can leverage the next time we come around to add an additional screen to this application or to add an additional chart. And this paid off for us actually just last week on Thursday. This ended up working out really nicely for us because we had this data in the background, and we realized, you know, what would be really nice is if we had a chart that was, you know, maybe total employee salary by month over time. Well, we had the data represented in the database in a way that we could efficiently query that. So we were just like, okay, well, what does it take for us to add a new line chart? Well, we basically come back to this part of the application, add a new analysis that basically asks for you know, the time and the dollar amount from this API. So we just added some JSON to this, and then we added a new property in our controller that expressed a relationship between that data that we got back and how to present it as a line chart. And then we dropped that line chart on the screen, and it just was done. It just came together really nicely. And it was because we had these separate orthogonal general utilities that we could redefine it, recombine in different ways that enabled us to solve a problem that we had never designed a solution for to begin with. So that's pretty much all I've got. It may or may not, I try to use things consistently. This is something I kind of put together as I was thinking about things like ontology and dissonance and how they relate to one another. This kind of relates sort of some of these ideas back together.